Hello everyone. You must have seen my previous video already, right? If not, please check that video. This is the continuation of that video. Once again, welcome to Charan Maths classes. Today I am with the second part of Sequences M series chapter for IIT Mathematics. If you don't know, I have launched the new course for IIT Basic Mathematics Concepts, which may be even useful for 11th class. So, in yesterday's topic, we have discussed what is an AP and the nth term of an AP or the common term of an AP. Now, we are going to check the sum to n terms of an AP. Here there is an example. Mukul plants one tree in his neighborhood park on the first birthday of his son. On second birthday, he plants 2 trees. On third birthday, he plants 3 trees, and so on. How many trees he has planted until 20th birthday of his son? The number of trees planted by Mukul. See, if you notice, Mukul has planted one plant on his son's first birthday, next 2, next 3, till so on, and they are asking us to find out at 20th birthday how many plants they have planted. What will we do here? We just add them, right? 1 plus 2 plus 3 plus till so on. It's 19 and plus 20. So, would you just sit and add all of those numbers? Okay, you may think, yes, it's possible. If I give you till 100th birthday or 200th birthday, what will you do? Will you just count till that? No, there must be some method, there must be some formula, right? To find out the total number of trees planted by Mukul, you have to write each number as mentioned above, but it would be tedious and time-consuming process, as I told you already. So, there is a formula for sum of n terms in arithmetic progression. You may notice here, it's an arithmetic progression. The first term here is 1, and the common difference here is also 1 itself. So, how can we find the sum of n terms of an AP? They have derived this formula, but actually it isn't necessary here. The final formula is Sn is equal to n by t into 2a plus n minus 1 into d. I am writing it down here. Sum of n terms of an AP is equal to n by 2 into 2a plus n minus 1 into d. This is one of the most important formula in arithmetic progressions. If you remember this, half of your questions are clear, because in the arithmetic progression topics, most of the questions are from sum of n terms itself. So this is the formula. And one important thing you can notice here is Sn minus 1 is Tn. I will show you an example. 1, 2, 3, 4, 5. So here 5 is the 5th term. So let it be as nth term, which is 5, and this is not S, this is A5 or T5, this is So they are telling the sum of first 5 terms. If we subtract from the sum of first 4 terms, we'll be getting the nth term, means the 5th term we can find out. For example, the sum of till 5 terms is 5, 9, 12 plus 14 plus 15. 15 minus 10, right? 1 plus 2 plus 3 plus 4 is 10. We'll be getting 5, right? 5 is nothing but the 5th term. That's what they have mentioned here. If we subtract an nth term, nth sum of n terms from sum of n minus 1 terms, we'll be getting that nth term. We have already seen the example here. Here the sum of 5 terms, we consider n as 5, is 15, and sum of n minus 1 terms, which is 4 terms, is 10. If we subtract, we are getting the nth term, which is 5th term, and that's 5. So what we'll be taking here? Now, these are some important things you can remember here. Now, for you, I have searched few problems and I'll do it in front of you itself so that you'll get better idea, means how to solve these type of problems. So, 1 minute. The problem is, first we'll write the arithmetic progression here, 4, 8, 12 until 200. 4, 8, 12 till 200. So this is the arithmetic progression, right? Sum of n terms they are asking. We don't know how many terms are there in it, right? But we know the last term is 200. So there is one more formula, or we can just derive it from the original formula itself. I'll show you. What is the formula for sum of n terms? You should remember this. N by 2 into 2a plus n minus 1 into d. Here we don't know how many terms are there, right? N value, we doesn't know it, but we can find out. See here, the last term is 200, so n minus 1 a into n minus 1 term is d, 200, right? Can we write this as n by 2 into a plus n minus 1 into d? What is this? In the previous video we have already discussed a plus n minus 1 into d is the last term of an arithmetic progression. So can we write sum of n terms is equal to n by 2 into a plus l, right? So if we use this formula for this question, then we can easily compute that problem. I hope you understand. I took this problem for you so that you can understand the new concept, that is a plus l. So this question I'll compute on for you. The arithmetic progression is so the progression is 1, 2, 3 till 120. They told sum of 120 terms. We know the last term is 120, but we'll just use the default formula, n by 2 into 2a plus n minus 1 into d. 60. I'm writing 60 here. N is equal to 120 itself. So 120 by 260, 2. A is 1, so 2 into 1 is 1 itself. N minus 1, which is 119 into 1. So it's 120 into 60, which is equal to 7200. So, sorry, 7260. So that's the answer. Now, I'll compute this problem for you all. Now, as per the formula, n by 2 into 2a, a plus l. We know the l, but we don't know the n, right? But we can find the l. How? We can just consider the nth term tn as 200. We don't know n value, but we can consider like that. So a plus n minus 1 into d is equal to 200, right? We know the a value here, which is 4, and d is equal to 4 also. So 4 plus n minus 1 into 4 is equal to 200. So n minus 1 into 4 is equal to 196. Now we can find the n value from this equation, and we can just substitute in the original formula n by 2 into a plus l, the n value, and we'll get this. Why I'm not giving the whole solution? Because you need to try it. You need to practice. Then only you'll improve. So that's all for today's video, and I will share today's assignment in the description. Please check it out, and I'll also provide the key for today's assignment. Please do it, and if possible, you can post the answers in the comment section. Yesterday's video's assignment was also posted in the description. If you have not seen it, you can do it now. Thank you, everyone.